this is Todd Frazee, and this is the video tutorial for the S60-117 part. This will be our first part that's going to have revolved and cut features in it. And we also have three parts, which I would call as a family of parts that share common features. So let's take a look at the PDFs for this assignment and the next three. So we have the 117, and on the left side of the part we have a slot with a through hole for a pin, and that's to accept another part that has this tang type of feature on the right hand side, or tab. So if you recall, when we made the rod end component, it had a feature that was similar to this as well. So this top notched piece connects to what's called the rocker arm. Now we have two other parts that have similar features. Here's the drive rod. So the left side of this connects to the rod end piece, and the opposite side connects to the return rod and the crank. And so instead of having a tab on it, it has a half round. And if we look at the return rod, it's identical to the drive rod except for the length and the centers of the holes. So what we're going to do is we're going to set up the first model, which has a lot of common features, same size, and we're going to model the 117, and when we finish that, when we go on to the 143, we will copy it and adjust the sketches and dimensions from the 117 model to make the 143 drive rod. And then when we copy that file, we should be able to just change dimensions to generate the 145. So you'll see how the time savings of a parametric system is pretty effective if you set up your models correctly with the datums that are called out that are common between them. Alright, so let's go back to the 117. We're going to do a revolve feature, which is going to make up more or less the profile we see. It goes around if you were not to have the notch in it. So our revolve feature will lack the notch, it'll lack the two holes, and the tab will be circular, and we'll come back and make cuts to make those other features. Okay, so let's go to SolidWorks, and what we're going to do is start off with basically starting a line vertical and then across down like a rectangle down the length. We'll put this chamfer in, we'll come across, put another chamfer in, come down to the center line, back to origin, and then we'll probably put these two fillets on as sketch fillets, because we could make them on the end, but at the end, but for this it's pretty straightforward. So if we needed to uprev the part, we would only have that one sketched uprev the entire profile. Alright, so let's go to SolidWorks. Okay, here we're in SolidWorks, and we're going to start a new part. Inch and ANSI, and we're making a part file. Okay, so we're here in SolidWorks, and we're going to make the plane. We're going to make our planes visible, and we're going to go to sketch mode. We're going to go to sketch tab, workspace, and we're going to create a sketch on the front plane. Now I'm going to start with all the dimensions on our drawing radiated from the right hand side, so that's where I'm going to park the right hand side origin, just so it's consistent with the drawing. So we're going to start at origin, and then we're going to come up, and we're going to make our first rectangle shape. We're going to go to the left. I'll zoom out a little bit. For the shaft, then we have a 45-degree angle, then we have a flat, another 45-degree angle. We come back to center line, and then back to origin, and you should have a enclosed shape now that's shaded. Okay, we're going to accept that, and again we're going to use a convention with a center line, so make sure you change to center line for this feature. And got a little accidental click there. And we're gonna pick right on the what would be the top plane where it intersects our sketch plane, and we're gonna make our center line shoot beyond, so it's just a little easier to select on for sketches. All right, so I don't know what scale our sketch is in at this moment, but I'm going to throw in some diameters and it'll start taking shape. So we'll start with the largest diameter, which we have is 197 thousandths. So we'll take the dimension, we'll go from the edge that was called to center line and down, so 0.197. Okay, it shrank down quite a bit because I drew the part too large a scale. Not a problem. We're going to exit the dimension mode, and what we're going to do is we're going to drag the features that should still be on the opposite line of center line back to where they belong, and we get the correct, closer to correct. Okay, so, and I do want to select on this dimension. We want to keep it at 197, but let's bump the tolerance up so that we actually see 197 there. Okay, so let's go back to our drawing and let's look at what we've got going on here. So our next largest diameter, it's actually called as a radius because it's split, is a 2 times our 0.097. So that's going to be our next dimension. We're going to go to SolidWorks, and we'll just go ahead and call that one like the drawing to a radius. So it'll just go to center line, 0.097. I'm sorry, 79. So it's 79 thousandths, and if we change that out, we'll get our correct decimal points. Okay, so we have one last diameter. It's the center shaft, and that diameter is 118 thousandths. And again, change it to 3 place decimals so we can see it. Alright, so we have all our diameters established. Let's go ahead and put in our fillets now, sketch fillets. So our first fillet on the left hand side is it's 10 thousandths. It's 0.01. It was set at 100. And we select our 2 edges and accept that. And then we have another fillet on this side that's bigger. Select our 2 segments, and if we reference our drawing, it's 2 times 30 thousandths on that side. So we just have to bump this up to 30. Alright. You might get an error about something not being defined, and it's because it has to update with the dimension that was there. And occasionally you have to just recreate the dimension where a corner was referenced. Okay, so alright, so we've got all that established. Now let's establish the distances from the end of the part to where each one of the segments are. So we're going to start with the closest one. So we're going to go from our vertical plane to the little line segment we have here. And the dimension, according to our print, is 138 thousandths. Okay, then we're going to go from origin again to our next point, which I believe is here. And if we go back to our drawing, it is 790 thousandths. So 0.79. That stretched our angle out quite a bit here. Alright, so hopefully that will get resolved with our next dimension. So we're going to go back to our drawing. And it doesn't call the top of that, and it does call the overall length. So what we're going to do is put an angular dimension in, and that should resolve the issue of that being stretched out like you see. So we're going to put in a dimension going from the one line to another line, and we're going to drag it inside, and it's 90 plus 45 because we are doing an included angle, so that would be 135 degrees. And our feature looks more like what our drawing has, and this portion's elongated because the overall length's too long. Alright, so now we're going to do our overall length. Back to origin. And according to our drawing, that dimension is 1 inch 80 thousandths. So we're going to change that to 1 inch 0.08, which is 1 inch 80 thousandths. So now that looks pretty close to our drawing. We have one blue segment right here. Okay, so we're going to put an angular dimension of 135. We'll accept that. And it's still blue because it doesn't know what the distance is. So we're going to put a linear dimension. And we want it to be like this. Then we need to reference our drawing, which has that at a 3 times 40 thousandths. So this is 1, 2, 3 times. We really only have it one place at this point because we haven't cut the notch. We have it 2 places, here and here. We're going to put 40 thousandths, which we're pretty close to already. Alright, so that's all adjusted. We should have a fully constrained sketch at this point. If you really want to have it clean, you can take your center line and attach it to either end. But it doesn't look like it's necessary to do that on a center line to make it fully constrained. We're going to go to a 3D view. We're going to exit the sketch, make sure it's still highlighted. We're going to go to Features, Revolve Base. Looks like it auto-selected my center line. You might have to select it. And we're going 360 degrees like the default says. And we're going to accept that. And we get this mace-looking shape or baseball shape. I don't know. It looks kind of like a German grenade from World War II. But anyway, at this stage, you should have it look similar to this. Okay, make sure you're saving. Saving off is the correct part number and revision. And now what we're going to do is we're going to put the slot in the end. So we're going to go to Sketch, and we're going to look at the top view just like it's described in the top view. And we're going to draw us a rectangle. Now I'm going to switch to the corner to corner to the ones defined by center because we want this on the center line. So I'm going to select. Okay, so that shape will always be centered on this line. And then we're going to put in our dimensions. So we're going to have a dimension from the bottom of the slot to the base of the part. And according to our drawing, that dimension is, and the depth is 866 thousandths. Okay, and that puts the bottom of our slot where it needs to be. And then our width, according to the drawing, is 68 to 73 thousandths, giving us a nominal mean of 70 thousandths 5/10. So we're going to put it 0.0705. Accept that. And I get our width correct. Now I'm going to exit dimension mode and drag the slot out so that it's beyond the part, because we want to make sure it cuts all the way through. And then I'm going to highlight the edge and highlight the end of the part and make those collinear. And that way, no matter what the dimensions change, that cutout will always be collinear with the end of the part. And I forgot to do it, but on this dimension here, let's change it to 3 place. So we're seeing the whole number. Alright, so that's pretty much done. We should have a pretty close to fully constrained. Looks like it's not constrained. Let's see what we're missing. Let's try a rebuild. I think everything's there. Sketch. Yeah, and it's fully constrained. Just need to be rebuilt. Okay, we're going to exit sketch. We're going to have that sketch highlighted. And we're going to go to features and we're going to do an extruded cut. Now let's take a look at this in 3D so we can see what's happening. So our extruded cut by default shoots out one-way blind. And we are going to do, you could do a through all, and then you put that in 2 directions, through all. Because our sketch was drawn on center line, we're cutting from inside of the part all the way out. Okay, let's accept that geometry, and now we've got our cut through there. Now we need to do something similar on the opposite end to build our tab.